So again, example 2 follows the same structure as all of these examples are going to. In this last little bit of our unit and the last little bit of our course. Again, the first thing I do when I look at an equation is I want to kind of match it up with something that I recognize. So again, because there's no square attached to my variable, this is linear, which means I'm only going to have one vertical asymptote and I'm going to have opposite signs. Okay, so I know those to be true. From here, I just need to identify my non-permissible values. And I want to get a couple points. So non-permissible values is when my denominator is set equal to 0, but it's not allowed. Okay, so moving things around, I get -1/2 x cannot be 2. And so x cannot be -4. Okay, so that's going to again be my vertical asymptote, which is what we're asked for up here. I can then figure out some points surrounding my vertical asymptote. So -6, -5, -3, -2 again, and I jump over my vertical asymptote because I know it's not defined. And I plug them in here. So -6 in for x. So that's -6 times -1/2 is +3. -2 is 1, and 1 divided by 1 is 1. -5 times -1/2 is +5/2. -2 is actually going to give us +1/2, but that's in the denominator, so we reciprocal that and we get 2. So that's kind of interesting. -3, if we plug that in, we get -3 times -1/2 gives us +3/2. -2 gives us -1/2. But again, that's in the denominator, that fraction, so we need to take the reciprocal, and that gives us -2. Now again, you can do all of this work. You've got loose leaf you can grab, scrap paper. I'm just kind of talking you through it mentally, and that's okay too. Just watch out when you're doing that because you can sometimes make mistakes, especially when we're dealing with fractions. So if we plug in -2 in here, we've got -2 times -1/2. Well, that's just +1. 1 minus 2 is -1. 1 divided by -1 is going to give us -1, and we get that invariant point again. So now I've got enough information that I can actually graph this. Because I'm dealing with exclusively negative x values, instead of putting my y-axis here in the middle, I'm going to definitely shift over and put it towards the right. So I've got more room to function. But I see that my y values are going above and below my x-axis, so I'm still going to have it kind of in the middle. I'm dealing with whole numbers, but again, I've got lots of room, so I can kind of spread things out. -2, -3, -4, -6, etc. +1. I'm also going to spread them out vertically because I'm only going to 2. So I'm actually going to go quite large here and go like that. 1 and 2. Okay, so again, playing with your scale so that it matches kind of what you're graphing makes complete sense, and you are more than welcome to do that. I'm going to use that red again just so it's visible. I'm going to put in my vertical and horizontal asymptotes to start. So vertical asymptote at x equals -4, and a horizontal asymptote at y equals 0. And asymptotes still need arrows on the end because they do extend to infinity. From here, I can plot my points, -6 and 1, -5 and 2. So again, I'm getting that sense of what my graph might look like. -3, -2, 2, -1, and that same kind of general shape, the general curve that's eventually going to get to my asymptote. There we go. Okay, and so I'm done part A. B is a matter of domain and range again. I said I would do this one in set notation. So the only restriction on x is it can't be -4. So I can say that x is an element of all the real numbers, but x cannot be -4. And I'm done. My range, similarly, it's everything except for that pain in the butt horizontal asymptote at y equals 0. So I can say y is every real number, but y, lines there, cannot be 0. So then my vertical asymptote then becomes defined at x equals -4. Horizontal asymptote is y 0. And finite.